All right. So still under the 2023 mass examination question, we are going to be taking the question number 2A now. And the question there says, if x cubed plus y cubed plus 3y squared equals 8, defines an implicit function, find dy dx. So let's get started. Um, we have the given function x cubed plus y cubed plus 3xy squared equals 8. Now we are asked to find dy dx. We are asked to find dy dx. Now, take note, given an implicit function, you have to differentiate each of them term by term. You differentiate the left-hand side and the right-hand side. So we are differentiating the left-hand side and right-hand side term by term. So if you differentiate this, we have d dx of x cubed. We are differentiating each term plus d dx of y cubed plus 3x plus d dx of 3xy squared, d dx of 3xy squared, and this is equal to d dx of 8. So you are going, this is the form we are going to have. So we differentiate this, differentiate this. But mind you, this is x, this is y. So differentiating this, we are using product rule. We are not keeping any of them constant. We are going to differentiate both x and y implicitly. So we are differentiating this using product rule because they are multiplying together, and differentiate this and get 0. So let's start the differentiation. So if you differentiate x cubed, d dx means differentiate this function with respect to x. So if you differentiate x cubed, you have 3x. So we have 3x to the power of 2 here. If you differentiate y cubed, you have 3y squared. But now, because we are asked to find dy dx, it means y is the dependent variable. Y depends on x. If you are asked to find the x dt, it means x is the dependent variable. X depends on t, and so on. So since we are asked to find the derivative of the dependent variable with respect to the independent variable, and the dependent variable here is y, and we are differentiating the dependent variable, we need to attach dy dx to it. We have to attach dy dx from chain rule. Take note, from chain rule. Now the next one is to differentiate this. But to differentiate this, of course, we have to apply the product rule here. But first of all, we have 3 constant plus 3, we open brackets. Remember, we have to differentiate this using the product rule. Using the product rule, this is our u and this is our v. And the product rule says that the product rule tells us u dv dx plus v du dx. This is our u, x is our u, and v is our y square. So applying this product rule, we have u there is x, so we are going to write x, then multiply by dv dx simply means differentiate v, and v is y square. So if you differentiate y square, you have 2y. So what we have here is 2y. But don't forget, because you are differentiating the dependent variable y, you have to attach dy dx from chain rule, and then you add plus this now, v. Our v is y squared. So we have y squared times du dx, and our u is x. So if you differentiate u, which is x, you have 1. You close our bracket, and of course the whole of this is equal to 0, because if you differentiate it, you have 0. So that's what we have. So the next thing there is evaluate. You have 3x squared 3x square plus 3y square dy dx plus, open the bracket, 3 times 2, 6, 6x y dy dx. The next one there is 3 times y square plus 3y square equals 0. So this is what we have. Now remember what we are looking for. We are looking for dy dx. So let's send every other term that does not contain dy dx over to this side. So what we have here is 3y square dy dx plus 6xy dy dx equals, if this comes over, become minus 3x square. Also, if this comes over, becomes minus 3y square. But we are looking for dy dx, so we can easily factor out dy dx so that we have dy dx into 3y square, because if you use this to multiply this, you have this back, plus 6xy, and this is equal to minus 3x square minus 3y square. So let's make dy dx subject of formula. We have dy dx to be equal to minus 3x square minus 3y square over 3y square plus 6xy, and that is our answer to that given problem. So this is the answer to that given question. Or if you wish, you can decide to factor out 3 here, factor out 3 here, and also factor this 3, then they cancel out. But you can still leave your answer like this. So that is the final answer to that given question. So let's move on to question number 2b. So we can proceed to question number 3. So still under question number 2, this is number 2b. The question there says, if the integral from 0 to pi over 2 x sine x dx is equal to the integral from 0 to 2 of ax squared plus 2x dx, find the value of a. So in this very given question, we have to find the value of this a. But to start, let's start by integrating this and obtain our answer, and also integrate this, obtain our answer, and compare both of them to find the value of a. That's what we are going to be doing here. So the first thing is to take this part here. I'm going to take this part, the integral from 0 to pi over 2 of x sine x dx. Now, this is a definite integral because we have a given interval 0 to pi over 2. Now, how can we integrate x sine x? Because x is a function of x, sine x is another function of x being multiplied together. So we have to use the integration by parts, which is also known as the product integral. So we are using the integration by parts here. And to start, let's state the formula. The integration by parts formula states that the integral of u dv is equal to uv is equal to uv minus the integral of v du. So this is the integration by parts formula. So what we have to the left hand side is what we have here. So what we have to the right hand side is what we are going to find. And what we have to the right hand side is the solution to this given integral. But the left hand side here is this integral. Now the question now is, what is our u from here and what is our dv from here? Alright, so we are going to use this acronym LIATE, where L stand for log function, I stand for inverse trig function, and A stand for algebraic function. T stands for trigonometric function. Then E stands for exponential function. So what we are going to do is, we said that let's look between these two, which is our U. We said we are using this acronym LIATE. So the first one there we have is log function, but we don't have any log function here. The next one we have is inverse trigonometric function. We don't have any inverse trigonometric function here. The next one we have is algebraic function, but we have an algebraic function here. X is an algebraic function. X squared is algebraic function. X cubed is also algebraic function. Then the next one we have is trigonometric function, which is sine x is a trigonometric function. So from this acronym, which one comes first? Algebraic function, which is A, comes first. So automatically our U is equal to X. Then the next one is trigonometric function. So our dv, from here, U first, then dv. Then our dv have to be equal to sine x dx. So our u is x. Then when our dv is the remaining term we have there, which is sine x dx. But what we are looking for from here is uv minus v du. So we know u already to be x. What about v? We don't know v, but we know dv. dv is equal to sine x dx. So to find v, we have to integrate both sides. Integrate both sides. If you integrate dv, the integral sign will cancel the differential sign. What you have there is v equal to, if you integrate sine x, you are going to have minus cos x. Minus cos x. So this is what we have. Then we are not going to add a constant c because we are still going to substitute it here. So let's continue. Please take note of this. Take note of this. If you differentiate sine x, you are going to have cos x. If you differentiate with respect to x of cos x, you are going to have minus sine x. Also, if you integrate sine x with respect to x, you are going to have minus cos x. Then, if you integrate cos x with respect to x, you have sine x. Please take note of these standard differentials and integrals. If you differentiate sine x, you obtain cos x. If you differentiate cos x, you obtain minus sine x. Then if you integrate sine x, you have minus cos x. And if you integrate cos x, you have just sine x. Please take note of this. So the next thing we want to do there is to find du dx. Reason, because we have du here, so we need to find du. So we have du dx from here. If you differentiate u with respect to x, you have 1. So cross multiply, you have du equals the x. So since we have obtained du, we know u, this is u. We know v, this is our v. Then the next one is du, this is our du, which is the x. So we can now substitute into this given formula. So what we have there is the integral of v du, the integral of u dv rather, but our u dv now is x sine x dx. But don't forget, the integral is going from 0 to pi over 2 of x sine x dx, and this has to be equal to our u is x, so we have x into v. Our v is minus cos x minus cos x. We close our bracket. But because we have a boundary condition, we have an interval going from 0 to pi over 2. So we need to apply that interval here. We need to put the interval. So the interval there is from 0 to pi over 2. Then the next one there is minus the integral from 0 to pi over 2 of v du, but v is minus cos x, minus cos x, then du from there is equal to dx. So what we have here is minus x cos x from 0 to pi over 2 minus minus plus plus the integral from 0 to pi over 2 cos x dx. So what we have here is minus x cos x from 0 to pi over 2 plus, remember from the standard integral I've just cleaned, if you integrate cos x, you are going to have sine x. So what we have there is plus sine x, but don't forget our interval will still remain from 0 to pi over 2. So the next thing we are going to do is to substitute the given interval. So let's start from here. We are going to, in place of x, anywhere you see x, you put pi over 2. So we are going to have minus first. This is going to give us minus, open your bracket, x now, we put pi over 2. Pi over 2 into pi over 2 cos, in place of x, we put pi over 2. Then the next thing we are going to do, from pi over 2 to 0 is always a difference, minus. So we want to evaluate this interval. So we have to attach minus there. Going from here to here is minus. Then you open your bracket. In place of x, you substitute 0. So we have minus first here. Then into, in place of x, we substitute 0. Cos, in place of x, we put 0. So we have just evaluate this given function. Then the next one we need to do is to add plus sine. We said in place of x, we put pi over 2, pi over 2. Then from here to here is minus, minus. In place of x, we put 0, sine 0. So let's evaluate and see what we have. Let's evaluate and see what we have. So if you evaluate this, you have pi over 2 minus pi over 2 cos pi over 2. What is cos pi over 2? Please take note. In evaluating, pi is taken to be 180. Please notice pi is 180. So pi over 2 should be equal to 180 over 2. And this should give us 90. So we are going to have cos 90. And cos 90 is 0. Take note, cos 90 is 0. So we have 0 here. Then the next one is minus minus. Minus minus, we have plus. Plus 0 times cos 0 is 1. 1 times 0 is 0. So we have 0 there. Then the next one we have is plus. We have said that pi over 2 is 90. So sine 90 is 1. So we have plus 1 plus sine 0 is 0. Take note, sine 0 is 0. So we have 0 there. So evaluate this out, and this should be equal to 0 plus 0 plus 1 minus 0. And this should be equal to 1. So we have seen that the integral from 0 to pi over 2 of x sine x with respect to x is equal to 1. Now let's evaluate the second part of that given question. We want to evaluate the second part of the question. All right, so the second part of the question there was the integral from 0 to 2 of ax squared plus 2x dx. So we are going to quickly integrate this. Integrating this, we have integrate ax squared, you have ax, add 1 to the power 3, then you divide by the power 3, plus 2, add 1 to the power, you have x to the power of 2, because this is 1 plus 1 is 2, then you divide by the power 2, then the boundary conditions still remain from 0 to 2. So what we have here is ax cubed over 3 plus 2, we cancel 2, x squared from 0 to 2. So let's evaluate this. We said in place of x, you substitute 2. We have a into 2 raised to the power of 3, 2 to the power of 3 over 3, plus in place of x, you substitute 2, 2 to the power of 2. All these have to be in brackets. Then also we said that going from 2 to 0 is minus. Then in place of x, you substitute 0. A into 0 to the power of 3 over 3 plus 0 square. So this is going to give us a 2 to the power of 3 is 8. So what we have there is 8a over 3 plus 2 to the power of 2 is 4 minus the whole of this is 0, and of course this is also 0. So this means that we are going to have 8a over 3 plus 4. But if you could remember, the question did not ask us to find this. They asked us to find the value of a. But we have seen that this integral from here, this integral is equal to, the integral is equal to 8a over 3 plus 4. But if you could remember from the question tells us that this very integral is equal to this integral. From the question, let's rewrite that very question. So the integral tells us that, but the integral from 0 to pi over 2 x sine x dx is equal to the integral from 0 to 2 of ax squared plus 2x dx. So we can now compare. This integral gives us 1 from here. So we have 1 equal to, and this integral gives us 8a over 3 plus 4. So let's quickly find a. Send this over. We have 8a over 3 equals 1 minus 4. And this is equal to minus 3. So we have 8a over 3 to be equal to minus 3. So this implies that we are going to have 8a to be equal to minus 9. So a should be equal to minus 9 over 8. And that is the answer to that given question. So a is equal to minus 9 over 8. To verify, you can substitute the value of a into this integral. Substitute the value of a equal to minus 9 over 8 into this integral and integrate and see if you have this. Remember, this is equal to 1. If you substitute a equal to minus 9 over 8 into this integral and integrate, it must surely give you 1 to verify that you are correct. So that is it for that given question number 2b. So I'm going to see you in the next question, question number 3. And question number 3 is much more difficult than this. Remember, as the question proceeds, they get more difficult. So that's that. So if you are new to this channel, just subscribe and hit the notification button so that you will be notified whenever I upload new video under 2023 examination question. See you in the next video. Thanks.